You've been working on a lot of factoring, and we've not really done much with factoring besides use it to find some restrictions on denominators and to cancel out some rational expressions. Well, those are both good applications of factoring, but we're going to do another one today, and it's going to be based on this thing called the zero product property. It's a thing that you've known, gosh, if you're 14 right now, you've probably known it for 6, 7, maybe as many as 8 years, maybe even more in some cases. Because the zero product property teaches you or demonstrates something that you've known for a long time. Think back to elementary school math. If your teachers would give you a problem like this one, you would kind of like be excited about this because anything times zero, right? If you saw the times zero, all you needed to do was see times zero and you would automatically know the answer. You didn't even really have to think about the question. It was just automatically zero. Even if we switched these around a little bit and said 0 times 5, that wouldn't throw you off. You would just say 0. Even if we did 0 times 0, that would be easy. You would just say 0, right? The zero product property really only suggests that if you have two things being multiplied together, one or the other has to be 0. So let me show you what that means here kind of in practice. Here it is, written out. The zero product property says if A times B equals 0, right? We don't know what A and B are, but if there are any values out there, all we know is if we have two things being multiplied and they give you 0, then the first one or the second one or both of them, the first, second, or both, they have to be 0. And we can use this for a variety of things, right? Let me show you how to use this zero product property to solve a very simple equation. Now, by the way, today we're going to work on 3 different equations. We're going to go easy, medium, and then very challenging. Between those 3, that should be enough to get you through what you're doing today, which is solving quadratics with factoring using the zero product property. Now, this right here looks like about the world's easiest math question. And yay, we like easy math questions. But I'm going to do it 2 different ways. I'm going to do it the old school way. And just confirm that the answer is 0. So this shouldn't surprise anybody at all. But now I'm going to go the new school way. We're going to go ahead and use the zero product property. And what we're going to do is we're going to imagine that 2 and the x as 2 separate items being multiplied together, which is in fact exactly what's happening. Now what we're going to identify is that the first number, according to the zero product property, could be 0. The second number that's being multiplied together could equal 0. Or they could both equal 0 at the same time. Okay, that's pretty cool. Except common sense has to reign a little bit here, and there are times when we're going to find ourselves in a situation where one of the 2 or maybe one of multiple answers just doesn't make any sense at all. And in this case, you can probably imagine which one doesn't make any sense. And we're just going to eliminate that one because it doesn't make any sense that 2 would equal 0. Therefore, x has to be 0 in order to do 2 times blank is 0, right? X has to be 0. So without knowing it, that's an example of the zero product property. So easy question, done. But we could have done the easy question without the zero product property. What happens if we go to the medium level difficulty? So here we go. We have a polynomial set equal to 0, and we want to solve this thing for x. Now it's quadratic, so it's probably going to have more than one answer, although it could have no solutions. It could have one solution or it could have 2, just like our graph. You might recall that our parabola, when we graph them, however many times it touches that x-axis, however often it touches the x-axis is how many answers it's going to have. So if the parabola comes down below the x-axis and back up, it's going to have 2 answers. If it touches the x-axis and goes back up, or for that matter, touches and goes back down, it will have 1 solution. Or if it just doesn't go down far enough, or doesn't come up far enough, then we would have no solutions. Let's find out what we have here. So I need to turn this into a multiplication problem because the one thing that I'm sure of is the zero product property is not talking about adding or subtracting or even dividing. Product means multiply. So I need to do a multiplication problem and look for zeros. So one thing that I do have is I have my equal 0, so I like that, but what I don't have is multiplication. So over here, bad news for now. We're going to factor, and you could use your area model. This is a relatively medium level question for this video, but hopefully this is a rather easy factoring question for you. Now look what we have. We have the 0, which we like, and we have a product of two items, right? These two items are being multiplied together. So we have everything we need. We have a zero product. So zero product property is a good application here. So let's get rid of a couple little tangly things, and let's go ahead and talk about how we use the zero product property. You might already guess this. The first item is allowed to be 0. So x plus 2 could equal 0. Okay? I think that's one of our answers. Now let's talk about the second part of it. The second part, there's the first. The second part could also equal 0. Heck, they might both equal 0 at the same time. But right now, what happens if that stuff on the inside there, this thing, what if it equaled, literally, if it equaled a 0? Well, if x plus 1 equaled 0, that would mean x would have to equal -1. That's the only way it would work. So it looks like we have two solutions. Now, it is worth checking that these both work. I'm going to use a blue marker to check these out, but let's do them. So if we have x plus 2, or if we even go back to the original here, x squared plus 3x plus 2 equals 0. All right, let's put a -2 in there and see what happens. So -2 plus 3 -2's, there's the square, plus 2 equals 0. So 4 minus 6 plus 2, that's -2 plus 2, that's a 0. So that equals 0 just like it's supposed to. So we know the -2 works. I'm going to go ahead and box that one in. Now let's try the -1. Because I have an iPad here, I'm going to go ahead and just do a little bit of deleting. And put a -1 in there. And I'm going to get +1 minus 3 plus 2. That's going to be -2 plus 2. That's going to be 0. And that also works. So not surprisingly, they both work. And this is going to happen regularly. In most of the questions we're going to deal with, whatever answers you come up with, sometimes none, sometimes 1, sometimes 2, like in this example, they're both going to work. As we get further along, the questions will become more complex, and you might get something called an extraneous solution, which is not an answer at all. It's an answer that looks like an answer, but doesn't work. So checking it at the end, like I just did, is always a good strategy. All right, let's move on to the third style. We're almost at 7.5 minutes. Let's get this thing rolling. Okay, zero product property is the topic for today. I see neither a 0, So not only do I not see a 0, but I don't see a product. So I got a double whammy working against me, but I'm in an algebra class. I can manage this, right? First, I could do this. Whatever you do to one side, you can do to the other. Solve the problem of the 0 very easily. So we just got everything over to one side and had a 0 left on the other. So we like that. Now let's go ahead and make it into a product if we can. That means we want to factor it. So I'm going to give myself a little space. Right off the bat, I see a negative on my leading coefficient, and I never like that, so I want to factor that out. But I also happen to notice that these all appear to be even. In fact, they are even. So not only am I going to remove a negative with GCF, but I'm going to divide it by 2. So let's do that. So divide everything by -2, and I'm going to get 2w squared plus 3w plus 27. All right, so now I have a 0 and I have a product. However, this is going to be difficult to work with because it's still a polynomial and it's a trinomial. So we'd rather get 2 binomials if we could. So we're going to try to factor this a little bit more. Once again, this is where you'd use your area model. I've already done this question in advance of the video. So I'm going to have this, I claim I did it, but I'm going to make a mistake here. And by the way, a little shout out to the number of people that emailed things from the last task on Tuesday. You caught a lot of my mistakes. Good job. Shame on me. Good job for you. All right, here we go. I'm going to do a little double check here to make sure I didn't make any mistakes. 2w squared, good. 6 and -9 make, see, this is where I want to double check. 6 and -9 make -3, but I have a +3. Oh gosh, look at this. I've been killing this question. Okay, so that should have been a negative. You saw me just fix that. So now we're back on track there, and negative times positive is -27, and that means that this one should be a negative. So what I think that tells me is, just for the record, and you might have already caught this in the video, when I distribute it out, or when I used GCF and I factored out a -2. I forgot to factor out and divide by -2, so none of my signs switched. So that was shame on me, but I fixed it. So we haven't really lost any progress yet. I can get rid of this. And now let's go ahead and use the zero product property, because now I have a 0 and now I have a product and life is good. So zero product property, I've got 3 items. So -2 equals 0. We already know we don't really need that one. We have the 2w minus 9 equals 0, because any of these 3 items could be 0. And we have w plus 3 equals 0. All right. Well, one of these doesn't make any sense, so we're going to get rid of that one, as we wouldn't even call that extraneous. We would just say that doesn't make any sense. On the other one, we would go ahead and add 9. And we divide by 2. And I'm just going to go with the decimal here, 4.5. You could leave it as 9 halves. You could make it 4 1/2. That would be all fine. Oops. And w is -3. So I made a mistake with my GCF factoring, but we fixed it as we went. Because I double checked it, I found my error. I have 2 good answers. My video is over 10 minutes, so I'm not going to show the check right now because that'll take us to 12 or 13. But I do have 2 answers. They are both going to work. And that is how you solve a polynomial using factoring.